A common problem with real-world data is outliers. You'll always have, some strange users or some strange agents that are polluting your data that act abnormally and atypically from the typical user. And you have to decide what the right way to deal with them is. So let's dive into some examples of dealing with outliers. So sometimes your real-world data will contain outliers, and they might be legitimate outliers. They might be caused by real people and not by some sort of malicious traffic or fake data. And you have to decide how are you going to deal with them. So sometimes it's appropriate to remove them, sometimes it isn't. Make sure you make that decision responsibly. So for example, if I'm doing collaborative filtering, if I'm trying to make movie recommendations or something like that, you might have a few power users that have watched every movie ever made and rated every movie ever made. And they could end up having an inordinate influence on the recommendations for everybody else. And you don't really want a handful of people to have that much power in your system. So that might be an example where it would be a legitimate thing to filter out an outlier and identify them by how many ratings they've actually put into the system. Or maybe an outlier would be someone who doesn't have enough ratings. Or, we might be looking at weblog data like we saw in our example earlier when we were doing data cleaning. Outliers could be telling you that there's something very wrong with your data to begin with. It could be malicious traffic, it could be bots or other agents that should be discarded that don't represent actual human beings that you're trying to model. But if someone really wanted the mean average income in the United States and not the median, they specifically want the mean, you shouldn't just throw out Donald Trump because you don't like him. Fact is, his billions of dollars are going to push that mean amount up, even if it doesn't budge the median. So don't fudge your numbers by throwing out outliers, but throw out outliers if it's not consistent with what you're trying to model in the first place. Now, how do we identify outliers? Well, remember our old friend standard deviation. We covered that very early in this course. It's a very useful tool for detecting outliers. So you can, in a very principled manner, compute the standard deviation of a data set that should have a more or less normal distribution. And if you see a data point that's outside of one or two standard deviations, there you have an outlier. Remember we talked earlier too about the box and whisker diagrams too, and those also have a built-in way of detecting and visualizing outliers, and those define outliers as lying outside 1.5 the interquartile range. So what multiple do you choose? Well, you kind of have to use common sense. There's no hard and fast rule as to what is an outlier. You have to look at your data and kind of eyeball it. Look at the distribution, look at the histogram, see if there's actual things that stick out to you as obvious outliers and understand what they are before you just throw them away. So let's take some example code and see how you might do that in practice. Let's mess around with some outliers. It's a pretty simple lecture. A little bit of review, actually. If you want to follow along, we're in the Outliers IPython notebook, so go ahead and open that up if you'd like. And we did something very similar very early in the course where we create a fake histogram of income distribution in the United States. And what we're going to do is start off with a normal distribution of incomes here that have a mean of $27,000 per year with a standard deviation of 15,000. And I'm going to create 10,000 fake Americans that have a income in that distribution. Totally made up data, by the way, although it's not that far off from reality. And then I'm going to stick in an outlier, call it Donald Trump, who has $1 billion, and we're going to stick this guy in at the end of our data set. So we have a normally distributed data set around $27,000, and then we're going to stick in Donald Trump at the end. And we'll go ahead and plot that as a histogram, and you can see, wow, that's not very helpful. We have the entire normal distribution of everyone else in the country squeezed into this one bucket of the histogram, and then we have Donald Trump out here screwing up the whole thing at $1 billion. The other problem too is that, if I'm trying to answer the question, how much money does the typical American make? If I take the mean to try to figure that out, it's not going to be a very good, useful number. He's pushed that number up all by himself to $126,000 and some odd change, when I know that the real mean of my normally distributed data that excludes Donald Trump is only $27,000. So, the right thing to do there would be to use the median instead of the mean. But let's say we had to use the mean for some reason, and the right way to deal with this would be to exclude these outliers like Donald Trump. So we need to figure out, how do we identify these people? Well, you could just pick some arbitrary cutoff and say I'm going to throw out all the billionaires, but that's not a very principled thing to do. Where did 1 billion come from? It's just some accident of how we count numbers. So a better thing to do would be to actually measure the standard deviation of your data set and identify outliers as being some multiple of a standard deviation away from the mean. So here's a little function I wrote that does just that. It's called reject outliers. It takes in a list of data, finds the median, okay, and it finds the standard deviation of that data set. So what I end up doing is I filter that out, so I only preserve data points that are within 2 standard deviations of the median for my data, okay? So I can use this handy-dandy reject outliers function on my income data to actually strip out weird outliers automatically. And sure enough, it works. I get a much prettier graph now that excludes Donald Trump and focuses in on the more typical data set here in the center. So pretty cool stuff. So that's one example of identifying outliers and automatically removing them or dealing with them however you see fit. Remember, always do this in a principled manner. Don't just throw out outliers because they're inconvenient. Understand where they're coming from and how they actually affect the thing you're trying to measure in spirit. By the way, our mean is also much more meaningful now, much closer to the 27,000 that it should be now that we've gotten rid of that outlier. So if you want to play around with this, just fiddle around with it like I normally ask you to do. Try different multiples of the standard deviation. Try adding in more outliers. Try adding in outliers that aren't quite as outlier-ish as Donald Trump. Just fabricate some extra fake data there and play around with it. See if you can identify those people successfully. So there you have it. Outliers. Pretty simple concept. So that's an example of identifying outliers by looking at standard deviations and just looking at the number of standard deviations from the mean or median that you care about. Median's probably a better choice, actually, given that the outliers might be skewing the mean in and of themselves, right? So by using the standard deviation, that's a good way of identifying outliers in a more principled manner than just picking some arbitrary cutoff. And again, you need to decide what the right thing to do is with those outliers. What are you actually trying to measure? And is it appropriate to actually discard them or not? So keep that in your head.